All right, welcome back to Ideal Coder, Module 2, Section 1. So in today's teaching, we're going to be going over all the types of different programmers. So there's roughly 14 of them. So there is front end, back end, full stack, mobile application, QA and test, embedded engineering, database, data scientist, algorithms, DevOps, and OS, it's more system, and language compiler, again, it's more system. So let's dive deep and learn about these different type of programmers. So we have the first one, a web developer. This is the most popular type of programmer out there. So web developer is a front end and back end. So there's the front end developer, there's the back end developer, and then there's the full stack developer, which deals with both the front end and the back end. But let's dive deep into what is a front end, back end, and full stack. So front end is also known as client-side development, is the practice of producing HTML, CSS, and JavaScript for a website or web application so that a user can see that it interact with them directly. So you can think of front end as like the layout of the application, how it's laid out, like the buttons, the paragraphs, with Facebook, for instance, that's when you log into the app, that's all the front end. It's what you see. So, but the backend is the type of programmer who creates the logical backend and core computational logic of an app or a website, software or information system. So the backend developer creates components and features that are indirectly accessed by a user through a front-end application or system. So for instance, with Facebook, you don't get to see the backend programming, the functionality. So for instance, like if you were to click a button, you're not going to see the functionality of how that button will take you from profile to the messenger. That's the backend. It's the functionality, the backend functionality that takes you from point A to point B. So backend, again, it's the backbone of the application. It's the backbone of, for instance, Facebook. So you don't get to see how the core functionality, the core and backend functionality works. That's the backend developer. He works on developing these backend functionality of an app or software. So here we have a kind of an illustration of how this works. So again, the front end is what you see. So we have a rock inside of water. So you can see the top is the front end, is what you see. And then there's that cut in between the line. You see there's API, which communicates with the backend, or API can be thought of as like Google or some sort of an API that translates from front end to back end or back end to front end. So front end developer builds, the view. So it's the user interface. It's called the user interface or the client side logic. And the backend is about database management, cloud storage, user authentication, how you log in, all that information, how you log into the Facebook, how it's saved, your username and password, that's all in the backend being managed by APIs, databases, and cloud storage, user authentication, and such as other like push notifications or hosting. So that's the difference. So that's the difference between the front end and the back end. And then we have a mobile developer, which in this case we have two. So the iOS and Android. So with the iOS, we have Apple. So iOS, Apple iPhone. They mainly develop in Swift, a programming language called Swift or Objective-C. I myself, I'm an iOS developer and would like to pursue development in iOS. For Apple. So I've programmed in Swift and Objective-C. I know there's also Android that you can program for, and it's more Microsoft. It's a Microsoft, phone service computer, and it utilizes Java as a programming language. So then we have the desktop app developer. So your computer, that's called the desktop app development. You're not developing on like a regular iPhone, you're developing on your desktop, your computer, your PC. And that's also iOS. There's the iOS apps on computer, on such as a Mac or MacBook, iMac, or we have Windows, such as Windows. We have all sorts of different tablets with Windows and whatnot. So Apple again utilizes Apple Swift or Objective-C, and then Windows utilizes C# mostly. So that's the difference between Apple's iOS and Microsoft. And then we have quality engineer or QA, which is also known as a test engineer. So a QA engineer is a software quality assurance engineer, is someone who monitors every phase of the software development process, so as to ensure design quality, to make sure that there's quality in the software. Nothing is broken. When you click a button, it works, and if there's something wrong, the QA person would know and figure out where that issue is going, how to reproduce that issue, and then communicate that to the developers, to the front-end developer or the back-end developer. So making sure that the software adheres to the standards set by the development company, and the software quality assurance engineers make sure that new products work before they are released to the public. So again, I myself have worked as a QA engineer in one of my internships. I was monitoring the software process from all the way from development to testing to deployment. So I would come in and look at all the functionalities that's being produced and making sure that each and every single functionality of the app, of the software is adheres to the requirements of the software. So making sure that everything's working correctly, and if there is a mistake, if there's a bug, then make sure that to make note of that and see where and how that's wrong, where that incorrectness is happening, and communicate with the developers to make sure that they do change that before it's fully released to the public. So again, this is just a timeline of QA. So identify business requirements, determine product and performance specs, understand user needs through functional testing, develop real-world testing scenarios, and offer feedback to maximize UX and reduce costs. So a quality engineer, a QA engineer, is actually very, very, very important in software engineering teams. It's an essential role that need to be played, and that's just how they go about their timeline. All right, then we have the embedded system developer. This one is interesting because you're diving more into like the one thing that I can think of is like industrial materials, like machines, like statistic machines and whatnot, like more like tangible machines. You're not really like an iPhone, whatever, not like a PC, but like an actual tangible software machine, such as, for instance, your car. You have that TV set into it, or something more embedded. So embedded system developer is an embedded system developer write low-level code that powers a hardware system. That's the word that I was looking for, hardware system. This is the code that can potentially run before even an operating system loads, such as a keyboard, camera, and it's needed for hardware to function properly. So for instance, I have this keyboard here. This is a hardware product. So whatever functionality inside this keyboard is developed by an embedded system developer. A software engineer wouldn't come in and develop this right here. I would not be able to develop this right here. We would need an embedded system developer to help. I would develop, the functional side on the display interface, but the embedded software engineer would come in and develop this keys, the keystrokes and all the functionality that goes along with the interface. And then we have the database engineer, and this one also can be very crucial for larger tech companies, such as the big tech companies. For instance, Microsoft, IBM, Apple, all these huge companies. They would need a database engineer because there's so much data to be managed that they would need a specific engineer for that role. So a database engineer, they generally design and monitor complex databases. They must make sure that a database is operational and provides valid and relevant data. So they would work with queries, they would work with MySQL, Oracle databases, all these Azure databases. They would work with all these different database technologies and making sure that the database adheres, again, to the requirements of the software. And then this one's interesting. So a data science engineer. This one became a lot. This role is becoming more and more popular. Even when I first started in college as a freshman, this role was becoming more and more popular, and a lot of my friends were going into the data science engineer route. So the data science engineer is someone who develops, constructs, tests, and maintains architectures such as databases and large-scale processing systems. So these engineers would come in and, they would look at a huge chunks of data and figure out how to use them, how to kind of segregate them, how to work with different types of data in the system. They're more specialists in that area in software engineering. And again, those roles are extremely important when it comes to bigger tech companies, not the smaller ones, but bigger tech companies that work with more like, international data. So algorithms developer, this one is interesting. The job duties of an algorithm developer revolve around researching, writing, and performance testing algorithms. As an algorithm developer, your responsibilities include working to implement your algorithms and then to analyze and modify them as needed. Generally, algorithms use data from a system to generate actions, processes, or reports. So an algorithm developer is someone who, would look at a code, would look at a way of how something would work, like how our data would work, but then he would come in and actually try to make it go faster, better, in less time, in less code, which, this role requires someone who's extremely smart. Algorithms developer is someone who is really interesting at figuring out how to make data more proficient and efficient. So that's an algorithm developer. And then you have the DevOps engineer. A DevOps engineer works with developers and the IT staff to oversee the code releases. They facilitate better coordination among operations, development, and testing functions by automating and streamlining the integration and deployment process. So they oversee the entire kind of software engineer project, and like the development, deployment, integration. They would oversee these processes and making sure that these processes are going, as according to the requirements document. So they don't do so much with coding or like programming or developing, but more like overseeing, making sure that these processes are streamlined. So this is what some of the tasks that of a DevOps engineer. So be an excellent system admin. So sysadmin stands for system admin. So he's the system administration. He comes in and make tests, make sure everything software-wise kind of come in together, but not like the nitty-gritty, the code, not at the code level. So deploy virtualization, hands-on experience in network and storage, knowledge of coding goes a long way. Soft skills are must-have, and these are just some tips. Understanding the automation tools. So if there is like automation testing that's going on, so automation testing is like you're testing the software, but you kind of already programmed steps of how you want to test your software, and so it's automatic. So step one, maybe you log in. You tell a bot to log into your site. Step two, to add a friend. Step three, to send a message. Step four, to log out. If the system is able to go through that, then your test checks, it passes. If it fails at one of these steps, then it fails. The entire automation test fails, and then from there we would notify the developer, hey, you have a problem here, you have a bug here. So they need to have knowledge. So DevOps needs to have a knowledge of testing as well, and security as well, and security aspects of the IT organization. So they would need to know all the administration stuff, all the security stuff as well. So an OS developer, so operating systems developers develop the operating software that all out programs and processes run on. So an OS is operating system is the person who developed iOS or Android. So they develop the main core operating system, such as iOS or Android. So they work on. This one's interesting too, because as we go deeper and deeper, it gets harder. It kind of gets harder and harder. So an operating system is one of the most challenging. It's one of the most challenging software engineering role you can have. So again, they work on iOS. They develop iOS. They bring in, now there's more AI, artificial intelligence, that iOS is making. Same as with Android. So yeah, that's operating systems developer. And then compiler, language developer. I think this is the hardest software engineering role you can have, or as a programmer. So these developers specializes in creating programming languages. So these are the people that invent Python, Java, Ruby, C++. So these are the people that invent these languages, which is extremely difficult. So these developers specialize in creating programming languages. Those type of developers focus on studying the fundamentals and organization of how a computer language is structured. The compiler developer is writing the compiler that turn programming language into machine code that the computer can run. So it's an extraneous job. It's one of the, I had a professor that does that, and it's extremely, it's one of the harder programming fields that you get into. Now, I think that's a wrap for all these 14 different type of programmers. So an action step for this end of this section. So tell the Facebook group which type of programmer you want to become or that interests you. So this is an important action step. I want you to go in the Facebook group and type the type of programmer that you see yourself becoming or wanting to be, or that is interesting to you. All right, and that's a wrap with this section, and I will see you in the next section.